All right, so we've looked at solving. So I'm going to go back to our original equation, which was 2x plus 2y is equal to 6. And I'm going to plug in 5 for y. So I'm going to have 2x plus 2 times 5 is equal to 6. And so in this case, we're going to solve for the x now because that's the last variable. So I'm going to start with 2 times 5, which gives us 10. So now I have 2x plus 10 is equal to 6. We see that there's a plus 10, so we need to undo what has been done to this variable, which means we need to subtract a 10 from both sides. We have 10 minus 10, which is 0. And by additive identity, anything plus 0 is itself. That's why we get just this 2x. And then we also have to subtract 10 from the other side. So we have 6 minus 10, which is negative 4. So now we have 2x is equal to negative 4. Following SADMEP, we see 2 times x. We need to undo what's been done to that. So the opposite multiplication is division, so we need to divide by 2. 2 divided by 2 is 1, and by multiplicative identity, anything times 1 is itself. And that's why we get x all by itself. And what we do on one side, we have to do to the other side. So we have negative 4 divided by 2. We see that it's a negative divided by a positive, which gets us a negative, and 4 divided by 2 is 2. So we're going to get negative 2. So when y equals 5, we get that x is equal to negative 2. So our point is negative 2, 5. I'm going to move on, and we're going to do the exact same equation, but I'm going to do it in a different order just to show you that you're going to get the exact same answer no matter how you choose to do it. Okay, so this is the exact same equation. We're starting with 2x plus 2y is equal to 6, and negative x plus 2y is equal to 12. Just show you, we just solved the exact same one here. In the first one, we divided everything by 2 in the first equation, and then we solved for x first. So this time what we're going to do is we're going to solve for the first equation, for the second equation. So we have negative x plus 2y is equal to 12. I'm looking at this, and I see that it's probably going to be fairly easy to solve for x first again. So I'm going to multiply everything by negative 1 to start, just because we have this negative, and I want to get rid of that. So I'm going to distribute this negative 1 across, and now I get x minus 2y is equal to negative 12. So it changed the sign on everything, and now it's fairly easy to solve for x. I have an x minus 2y, so I'm just going to add 2y to both sides just to get x by itself. So now I have that, what is it that I have? I have x is equal to negative 12 plus 2y. So again, we've solved for x, but this time we solve for x in the second equation. So I'm going to plug this value, negative 12 plus 2y, in for x in the first equation. So the first equation is 2x plus 2y is equal to 6. So we have 2 times x, and as we found in the second equation, x is equal to negative 12 plus 2y. It's going to have 2 times x, which is negative 12 plus 2y, in parentheses, and then the rest of the equation, which is plus 2y is equal to 6. So now we're going to distribute this 2 across, and we have 2 times negative 12, which gives us negative 24, and then we have 2 times 2y, which gives us a 4y. So we have negative 24 plus 4y plus 2y is equal to 6. So we're going to add like terms. We have a 4y and a 2y. That's going to give us 6y, so we have negative 24 plus 6y is equal to negative 6. And so now we're going to move on to using SADMEP to solve for our variable, which is y. First thing I notice is that there is a negative 24, so we're going to do the opposite of that, which is going to be add 24. So we have negative 24 plus 24, which is 0 by additive identity. Anything plus 0 is itself. That's why we get 6y by itself. What we do on one side of the equation, we have to do on the other side of the equation. So I'm going to also add 24 to 6. We're going to get that equals 30. Moving on, there's still some SADMEP to do. There's no more subtraction or addition, but there is some multiplication. I have 6 next to the y, which means that we have 6 times y. In order to undo what has been done to that variable, we need to do the opposite of that multiplication, and the opposite of multiplication is division. So we're going to divide this by 6. We have 6 divided by 6, which is 1 by multiplicative identity. Anything times 1 is itself. That's why you get this y by itself. And what we do on one side of the equation, we have to do on the other side of the equation. So I'm going to also divide 30 by 6. 30 divided by 6 is 5, so we get that y is equal to 5. Now, if we go back to the original equation, when we solved for the first equation, you can see that we did indeed get that y was equal to 5. Now, the first time we did this, we plugged the 5 for y back into the first equation. So this time we're going to plug y equals 5 into the second equation just to show you that you will get the same thing either way. So we're going to plug y equals 5 into the second equation, which is negative x plus 2y is equal to 12. So we're going to get negative x plus 2 times 5, because y is 5, equals 12. And we're going to do 2 times 5, which is 10, so we get negative x plus 10 is equal to 12. And in this case, we're solving for x because that's a variable. We're going to use SADMAP. I see that there is a positive 10 or a 10 that's been added to the x. So to undo that, we're going to do the opposite of that, which is subtract 10. 10 minus 10 is going to be 0, and by additive identity, anything plus 0 is itself. So we get this negative x here is equal to, and because we added or subtracted 10 on one side, we need to subtract 10 on the other side. So we're going to do 12 minus 10 as well. 12 minus 10 is 2. So now we have negative x is equal to 2. We want to solve for x, not negative x. So we need to multiply everything by negative 1 in order to get rid of that negative x. And that gets us an x is equal to negative 2. So if we were to write this as a point, we would have negative 2 and 5. And if we were to look at the original systems that we did, then we also got negative 2, 5. So you can see that we can solve either equation first, substitute, and we can plug the variable into either equation, and we will get the same answer either way. So if you were to graph out these equations, you would see that they would intersect at the point negative 2, 5.